All right, Section 3, Powerplant Regulating System, Instructional School, American Locomotive General Electric Regulation Systems, Section 3, Power Plant Regulating System for the Locomotive equipped with 17 MG3 governor. With the power plant regulating of the system control of the diesel engine speed, the primary function for the whole of the diesel engine, whatever the constant speed is called for, the setting of the engine man, throttle with the speed is held constant in all loads. The power plant regulating system includes the following equipment: diesel engine governor, engine driven tachometer generator, engine control panel, hydraulic power system. The diesel engine covers the General Electric type of the 17 MG with electrical hydrological governor with control of the speed of the all American Locomotive company type, the 244 diesel engine, the type 17 MG governor is used with both the 12-cylinder and 16-cylinder 9 by 10.5-inch diesel engine with the diesel engine speed with the control of the regulating rate of the fuel injection, adjusting the engine load. The governor includes the speed control equipment, the fuel limiting equipment, the speed controlling equipment. See Figure 24. The speed coil of the speed cylinder receive the control of the current with the engine driven with the tachometer generator with the solenoid operate with the balance four-way with the pilot valve with the control of the flow of the oil. Those the slave piston number to warm the piston when which move the flow of oil against the top of the bottom of the strip with the rotate shaft with the eve loader rotates. The governor output with the shaft F through the output travel the spring with the match for oil. Such F control of the position of the diesel engine fuel injection pump rack. The brush arm with the stabilizing rheostat 125 amp. Low with the control restamp 125A with the 125 and 125A. The brush arms are actually gear driven the shaft E, but they are shown directly with the given driven in figure 24 with the clarity in figure 44 with the illustration of gear driving. Fuel limiting equipment figure 24. The fuel limiting coil fuel limiting solenoid receives the control current with the locomotive there. The solenoid also operates the balance of four-way pilot with the valve with which control of the flow of oil to the slave piston number 2 movement of this piston either up or down with into the cylinder rotates the shaft H with the one end with which the fuel limit cam the shaft H position with the cam in such a manner with the limit of the travel of arms of A and B with a certain defined position. Each of the throttle notch resolve with the maximum allowable rate of fuel injection. Each of the position with the engine throttle with the shaft H with the also operates the brush arm with the fuel limit of the rheostat. The rheostat acts with the variable resistance and the fuel limit of the circuit with the tubes actually given gear driven shown in figure 44. Engine drawing tachometer generator. This is the three-phase, two-pole electrical current, alternating current generated with a permanent magneto-alkylico rotor. The rotor is gear driven with a diesel engine camshaft with the tachometer generated to use with the speed measuring device because of the output of the proportional diesel engine speed. It is current rectified direct current with about three-phase cilium rectifier. The rectifier current was supplied with the speed coil with the speeding solenoid, which is used with the control pilot valve action. An alternating current is used to eliminate the communication problems with the tachometer of the generator has no commutator and slip rings with no brush. For the radiator of the diesel engine, the speed of the tachometer generator speed is 1 to 3.42. The diesel engine speed of the 1,000 RPMs result of the generator speed of the 420 3,420 amps, RPMs. The connection with the diesel engine camshaft, the gearing is through the vibration dampener flexible coupling. Your engine control panel contains the control apparatus for operates the conjunction with the diesel engine government. The hydraulic power system. The motor driven supply of the oil under 120 psi regulated pressure of the pilot valve with the operating of the governor slave piston with the system and it includes suitable filters that strand as well with the oil as pressure regulating valve. The system is not connected with the diesel engine lube oil system. It's completely separate system in itself. Operation of the governor. The figure 24, the mechanical schematic of the diagram of the type of the 17 MG with the governor. The mechanical schematic diagram of the core of the design illustrate the various parts of the equipment of the true shape inside. The purpose of the rather is to give a clear picture of the inner working of the governor. To do this very part of the separated from one another so that each is visible. This would not be possible in the ordinary type of the construction diagram. The type figure 44 of the one plane, the schematic drawing show the various parts of these true forms. The figure 24 illustrates the action that would take place for the governor if the load increased load to the engine below the rated speed. The governor in function but to increase the fuel injection and bring the back of the speeds back to normal. Move the fuel injection pump racks to L to the right is viewed as the diagram. To do the slave position, number one has been forced upward into its cylinder by the flow of the oil through the speed pilot valve, with the teeth of which with the middle with the side of the slave piston mesh with the teeth of the gear J. Upward movement of the slave of the piston will force the shaft E towards the CCW within the gear J. The lever D turns the shaft E with the lever C is moved the conjunction D with the over-traveling spring with the inner coil with the over-traveled spring is fastened to shaft E, but so that the later turn it keeps the tension of the spring. Lever C with the support with the bearing of the shaft. The E with the pivots on the E like a seesaw as the C pivots with the pull blank of the M in an upward direction to pull the arms A and B to the right. The arm B is key with the output shaft. The F and B is moved to the right and it turns F the clockwise and to increase the fuel to bring it into the engine rate of speed. And the diesel engine load with the decrease of the engine speed would have increased beyond the rate of the RPM, but that has been open the shaft piston with the one would have been four for the downward and flow of the oil to the top of the cylinder and K for the shafts of the F, who have turned with the counterclockwise to pull the rack L to the left and thrust the grease for the fuel injection. The movement of the slave piston once control with the speed pilot valve with the plunger position the plunger the mechanically connected with the speed solenoid's movable armature. As the plunger moves up and down with the ported cylinders that cover the ports with the permanent the oil of the hydraulic power system reach and move the slave piston. The current with supplied with the speed coil with the tachometer generates will determine the plunger position of the diesel engine with the rotating is proper the RPM. The tachometer generator will supply the speed coil with the current with the 470 milliamperes or 0.475 amperes. Solenoid operation. The speed solenoid consists of the movable iron core with the position with the coil wire with the speed coil. With the speed design of the engine running with the tachometer generator supplied with the speed coil with the current with the solenoid coil core will be pulled up to its uppermost point of travel. The reference of the spring of the pilot valve will also be with the uppermost point of the travel because of the mechanical fastened to the solenoid core. When the engine is running, the tachometer generator will be supplied with the current to the speed coil. Passes the current with the speed coil will set the magnetic field within the solenoid. The magnetic core pulls it in downward direction. The reference spring with the core of the compressor spring with the lens of the insert with the exert upward pull with the core with the downward magnetic pull will keep the plunger from going back to back with the current of 475 milliamperes is the flowing through the speed coil enough the magnetism to develop the pull the pilot valve plunger into the position shown in figure 25. The reference as the balance position 475 amperes is reference as the balance current. When the plunger is balanced position with the pilot valve with the inlet with the bore with the blocked up with no oil can flow through it, the half with the diesel engine should slow down with the increase of the load with the slow of the tachometer generator with the weak of the current with the generator supplying with the speed coil with lead less than 750 milliamperes with the current with the coil with the magnetism will also weaker. The weaker magnetism will be unable to hold the plunger down and its reference spring can pull up and upwards with the shown figure for 25A. This permits the oil flow through the now open with the inlet port with the bottom of the slave piston. Number 1 reference 24 will show the upward movement of the piston cup of the fuel injection pump rack L2 increase the rate of the fuel injection the course with the speed with the diesel engine up as the diesel engine speeds over the tachometer speeds up with it. With the engine reach of the rate of speed of the tachometer generates up a slowing 475 milliamperes to the speed coil of the plunger will be pulled down with the block of the inlet port with once again that prevents further movement of the slave piston. In the diesel engine, the load has decreased instead of the increase the engine would have the speed of the tachometer generator would drive faster even enough to the current about 475 milliamperes. The storage of the current, stronger current would increase the magnetism sufficiently to plunge downward from the balance position 45 to the position of the shown 45B. If the action would have to cover the slave position downward to increase the rate of fuel injection, thus bring the engine down to rated speed. Once again, the change of the diesel engine speed with the RPM will result with a sufficient speed coil with the current change with the move of the pilot valve plunger 4 thousandths of an inch. The pilot valve of the plunger is therefore very accurately controlled with the tachometer generator current. Governor clutch arms A and B. The governor output of the shaft of the KF is keep with the arm B with the operate with it together with the one assembly because the shaft F becomes the fuel injection pump liquid change with the movement of the pump racks increase with the decreased speed with the arm B must move in the first. However, the slave piston move the change of the fuel is called for the connected with the arm A, and arm A moves the response with the slave piston movement. When the diesel engine is not running with the bypass spring, the bias springs keep the A and B part B apart. In order to operate with the diesel engine, necessary to bring the arms A and B together to operate in one assembly. Because they have no mechanical connection with one another, they are together magnetically by the flow of the locomotive battery current for the clutch coil and current flow through the coil magnetism of both the arms enable them to stick together. Our figure 25 shows the piston balance with the position of the engine speed with the save with the movement of engine fuel injection. The tank, the drain to the tank, the strainer, the pump, the filter, the pressure regulating valve, the slave piston, and the governor different size of the, you can see the hydraulic moves up on the spring here through three different, two passageways from the slave piston ways into, which looks into a sliding three-port. Figure 25 has a slowdown and low with the increase of the generated current is work with the to pull the upwards. The upward motion of the slave piston pushes the governor up into the drain and the fuel pump. The engine and the speed of the load, the decrease of the generated current, the decrease of the plunger is pulled down and stronger magnetic field and oil pressure are forced into the down. When it moves down, fuel from the fuel is drained in the tank. The fuel pump comes up into the governor and also around this piston slave pushes the piston down to drain back in the tank. Alright, this shows your your rectifier in a block of three in the same direction. This is a three-phase self-element rectifier. The self-element rectifier using the blocking rectifier, a full colored arrow with a line in front of it. A coil is a zigzag. A tube resistor is basically a box or a tube slidden over a plain line. Rheostat is a gauge, semicircle arrow connection. Contactor on motor cutout switch. CO with a double boarded truck. Governor off switch. Same thing. Normal open relay contact is a door swing. Normal closed relay contact is a closed swing. Hydraulically operated governor oil's positive switch has the GOP switch sign on it, which also looks like a motor contact switch or governor off switch. It's a hydraulic operated switch with the operation 1 and 2 with the represented symbol of oil. Your buck crossing, and it says EC. This is your engine control switch layer. The following EC with such as the 2-4 S, etc. indicate the position of the switch with the closed with the contact is closed with only two positions when the ISR and OIR are listed with the contact with these positions. Also the positions 2, 4, and 6 and other the two case with the contact closed on position listed. Your alpha magnetal plug point shows an A around a square, and your capacitor is two lines connecting two couple is like a coupler. Alright, your complete governor switch wire diagram will start over here from the exciter. You go through operation system 1, BB, closed circuit, you had a contact motor cutout switch in the first circuit with the operation 1 and BBS closed circuit operation. There's a coil that runs from OPR to the ops 2. Same thing, governor off. Engine control switch is tube rectifier 129 rheostats 127 121 127 AB. Engine control switch ISR rheostator. You have a whole bunch of rheostators, 132 series, going across the CV and DBS breakage of the AVIA. Relays, DBR, DBS, BBR, OBS, engine tachometer, engine tachograph receptacle, bivalve number 1, stab of speed current, magnetic control negative, 3 to 2 cell battery, and the main control positive, polyvalve number 2. Alright, this is your complete governor schematic wiring diagram for the road and passenger locomotives. Starting over here, the battery cells, you have the main control negative going down, and main control positive, negative, and some closed FPCs, fuel pressure control switch, ISC rheostator, IB control, pilot valve number 2, rheostator. A whole bunch of rheostator 130 series. Again, your gates GVS, CVS, BVS, GR, OPR, engine tachometer, and through the three-phase seldom rectifier, three-phase seldom rectifier, engine tachometer, engine tabs over receptacle, CAR, a capacitator, and then pilot valve number 1, some rheostats 127 series, the engine control switch. Your engine control switch OIR, ISR, field wiring, and your from the exciter, capacitor to the reciter. Try to do as best as I could, but it's going to explain it on the outside. All right, starting the diesel engine. Alright, starting the diesel engine. Figure 27 of the reproduction of the section D with the schematic connections diagram of the All-American Locomotive Company within General Electric Road Locomotive Type 244 diesel engine. Figure for the 26th production section D with the road switch. Small diagrams following the text and the representation circle analysis. Figure 27. To start the diesel engine, necessary to energize the pass current through the stabilizing coil with the speed solenoid. Stick with the diagram of the figure 28 with the main battery switch with 100 main control positive negative circuit breaker is 136 control with the 136 are closed to bring the locomotive battery current to wire 15 feet of the fuel pump contact the FPC. The scope with the circuit breaker 169 with switch 170 the section F the connection diagram. The scope with the circuit breaker 173 with the clove with the send current through the wire 71 from wire 71 enter the governor circuit with the diagram in the figure 26. Alright, so you have your battery going through 100, which is your switch. Your main power is by battery negative power and battery negative and power switch. 136 is your circuit breakers. 173 is also is a circuit breaker which the closed to send the current wire to the 71. 71 goes the engine control switch ISR. From engine switch ISR goes to engine OIR, and then goes to circuit breaker, closed circuit breaker SAR tube resistor 129, continues down to SIAB, and then back to the battery negatives battery. Engine control switch, engine control EC. The switch EC is placed in idle position. The closed contact with the 7150C to promote the current with the flow of the direction of air with the stabilizing of the coil with the current with the coil pilot valve plunger with the pull down with the position figure 25D with the oil flows through the pilot valve force to slave the position of the bottom of the cylinder shaft E with the turn with the clockwise to pull the turn arm B over against the arm B. Arm A over the against arm B. As arm A breaches arm B, it closes with the governor off the interlock with the interlock closing with the making the current with the wire 50C with the governor clutch with the coil now magnetizes A and B to hold the together with the engine control switch E engine EC with the show now turned with the start position engine starting switch is turned into the 50C and 50N contact with DC energizing stabilizing coil that allow the pilot valve plunger to be pulled onto the top of the travel to prevent reference spring with the oil flow against the bottom of the slave piston number 1 the piston then force upwards and the arms A and B move to the right of the cause of fuel injection. Alright, this shows your this shows your engine control switch in the idle position going down from wire 50C to the governor off switch. 50D and clutch coil to the operating switch 50H and through operating switch 50E. Closed governor oil pressure reaches at 75 psi. Closed circuit relay 55F and engine ESC ASR, which is probably engines. I can't think of the engine. ESR engine something relay switch. Or the sequence of events is as follows. The engine control switch, the idle position, engineering, stabilizing, coil speed, cylinder over the battery, coil, the pilot, valve plunger with the downward oil reaches the slave position, force it down, the force of the arm, the A to move the arm B with the arm A, close with the governor off switch, the engine energize the clutch, coil with the magnetized A and B arm, the engine control switch, start button, the de-energized, stabilize the coil, allow with the pilot valve with the plunger to be pulled upward with the reference spring, oil reaches the bottom slave position forward up with the arms A and B, move with the right with the cause of the fuel injection to begin. The starting switch of the also path with the current with the contactor ground GS1 with the ground contactor GS1 GS2. Section H with the schematic connection diagram, the contactor path with the current starting with the field main generator. The generator rotates the engine with the fuel injection rotation. The engine will begin to run. When the arms A and B move to the right with the arms relief with the governor interlock with the keep the clutch coil alive with the starting with the switch contacts 50C and 50D and figure 30 with the scope with the switch with the start position switch with bypass current around the now open governor off the interlock. Your diesel engine begins with rotating the lubricating oil pressure builds up. The oil pressure builds up to 7 pounds per square inch. Go for the oil pressure switch number, the number OP operating switch 2. Figure 31 with the I engines reach at the speed of 150 RPM with the tachometer generated current will strongly energize enough to energize the safety relay SAR with a later close with the 50C 52 contact. Or your temporary clutch temporary clutch circuit. Alright, if you show the figure 30 with the temporary clutch switch, starting switch contact, 50C and 50 D3 for the governor off switch. The engine control switch, idle position, engineer control switch, governor off, the clutch coil with the operating switch at 50H, 50E with the governing GOP, closed gate, ESR engine safety relay, running clutch coil, engine control switch, idle engine off, the idle SARP, safety, starting alert position, now open, 125, rectifier, 220 coil, GOP, SAR, OS, clutch coil, closed by 7 pounds of pressure with the OPS and the SAR, 52, closed with the tack of the generator current with the engine control switch. This completes the final running of the clutch curve with the diesel engine. Will now continue with the run life of the clutch circuit with its open with one with the automatic safety interlock with the OS, GOP, ESR, SAR, OPS2. This should happen with the clutch coil will be de-energized with no magnetism to hold together the alarms A and B will separate with the bias. The spring of the action would pull the arm B with away from the left of the minimum rack travel would result. No fuel injection of the engine would shut down with the SAR energized with the open with the F50NP and 50N and 50P contact stabilizing coil circuit with the prevent the current return with the reaching the stabilizing coil with the engine control switch. Return with the idle position. After starting, the diesel engine will come with a speed of 350 RPMs. The speed of the tachometer generator will supply the speed with a 475 milliamperes. The pilot valve will be balanced in Figure 25 as long as the engine speed remains at 350 amperes. Alright, your speed control switch. The circuit within the tachometer generator supplies the speed coil with the current illustrated in Figure 32 with the circuit the current flow with the direction air with the three-phase rectifier 133 with the rectifier with the alternating current through the tachometer generator direct current of the for using the speed coil. Alright, Figure 33 shows the tri-cylinder rectifier, the tacho generator, the two rheostats 132 and 132H, the ABS switch, CBS, and BBS switch, following the core down to the coil, and then through SAR and back on circuit. Your speeds coil circuit through the idle and first notch. Alright, engine speed is dropping below 350 RPM. The tachometer generator slow for the current with the pilot valve speed with the coil to drop at the 475 amperes within less than 475 amperes. The speed coil reference spring pulls by the pilot valve plunger upward with the oil pressure reach at the bottom of the slave piston number 1 to push the piston up, piston operate with the governor linkage to increase the fuel injection with more of the fuel engine speed without the rise when speed rise to 350 miles RPM. The tachometer generator will once again put up the 475 milliamperes with the speed coil. The current will cause the pilot valve plunger to pull down with enough far enough to block off the inner inlet port with the stop of the oil flow for the flower piston further increase if the fuel is prevented. If the engine had speed, but instead of the slowing of the below 350 RPM, but the governor would have decreased the flow of fuel instead of the increasing it. Effective throttle movement of the governor. The engine control switch must be turned for the 2, 4, 6, or the run position before the move of the engine throttle will have any of the effects of the diesel engine. As long as the resistant tachometer generator circuit remains illustrated in Figure 32, but the diesel engine will operate with 350 RPM, but the engine man desire with the increase the engine speed of the notches up the throttle when the throttle is notched up from 1 to 2. The cover the 7A15 contact to energize relay ABS picks up the contact tachometer generator circuit with the add rheostat 132A to the circuit. This adds resistant weakens of the tachometer generator current with the current of the speed coil with the after low 475 milliamp. The design amp engine will increase the speed with the Figure 25A with the diesel engine speed with increase. The tachometer generator will rotate faster, develop more voltage. 450 engine RPM. The voltage will be strong enough to bring the current to the 475 milliamperes. Once again, in spite of the added with the resistance of 132 amp, the resistance of the 132 amps, the current value of the low plunger down with the balanced position, cutting off the flow of the oil with the slave piston. The diesel engine fuel racks will now have the higher setting of the engine while operating with the second notch speed of 450 RPM, but the governor will hold at 450 RPMs until the throttle is moved again. Movement of the throttle through positions 2, 6, inclusive of the operating speed setting with the ABS, BBS, CBS, DBS. Every time the notice that the valve these are the valve settings of the A, B, and C and D. Every time the throttle is notched up, would done more than these relays operating with the chain of the resistant tachometer. The general circuit the resulting chain of the diesel engine. Figure 35 illustrates the complete circuit with all 4 relays, all with the 132 rheos and all 132 rheos at the dial line. Dotted line indicates the 4 contacts for the connect the operated simultaneously with the relay ABS. For the Figure 33 illustrates 3 throttle contacts TH, which cover the relay contacts. Alright, your source relay battery negative and positive negative relay 181 throttle indication the DMR contact, the ESR contact. Your TH throttle contacts between your engine control 6, 4, 6R, 6, and CBS contact, engine control R, BBS, ABS, BBS, CBS, DBS. Or your relays, your tachometer, generator, technocylinder, rheostat 132 series, 31 wire running ABS, BBS, CBS, and BBS. Speed coil circuit for the second notch into the speed coil, and then back to the SAR tachometer solenoid speedometer. Or your speed circuit with the 132 notches and notches idle from R2H 132H to 132G. It's notch 2 through 8. You have your AB, and CBS relays, ground relay, operating relay. Running through the connection to the rheostat, and also on an outside connection to the speed coil, SAR coil, coupling 128 and 148 and then the tachometer rectifier solenoid engine tachometer generator RPMs. Your fuel limit circuit, the rheostat once again from idle to going following the alphabet A B C D E F G. All such is from idle to notch 8. Your different valve settings, your ABV, DBS, DBS. Valve settings set the different notches for the rheostat with this arrow to indicate the speed indicator. With the you have your rheostat 131, 162, 124A. Control op. You have a fuel coil, engine control switch, ISR. 173 circuit breaker, rheostat, fuel pressure control, positive negative battery. All right, table 4 lists the relay with the operative air throttle with the position of the diesel engine RPM with the result of the various relay combination. Type 1 or idle none of the 350 RPMs. 2, the AVS relay operation 450 RPMs. 3, the CVS RPMs 550 RPMs. 4, the AVS and CVS is 655 RPMs. 5, the BVS, CVS, DVS 765 RPMs. Idle 6, the AVS, BVS, CVS, DVS 860 engine RPM. 7, the BVS, CVS at 92 RPM engine RPMs. 8, AVS, BVS, CVS at 1,000 RPMs. All right, your fuel limiting system. Whenever the diesel engine is slowed down with the increase of load, whenever the throttle is notched up, the speed limit of the valve with the increase of the fuel with the forcing arms A and the B of the right of view with the figure 24, have the movement of the arms A and B with the diesel engine fuel rack with the operate limited term with the staff with the travel, the throttle notch the arms move with the right that can come against the fuel limit cam with the cam prevents the fuel increase as long as the throttle is not moved in the higher notch by the limiting the fuel injection certain fixed amount of the engine so each of the throttle position designer ensure for the given set of the operation conditions certain horsepower will develop with each of the throttle not regardless of the grade of the tonnage and conditions. Fuel limits to prevent the injection of more fuel with the diesel engine can serve to satisfy safely burn. Excessive fuel is injected with the diesel engine at high combustion pressure for the temperature of the excessive the carbonization valve of the cylinder heads and manifolds pistons result. Let's assume the engine operating with the second throttle of the notch position, but the engine notch with up the number of the 3 notch and the arms being moved and the move with the right and the engine speed increase. However, the arms hit the cam and the fuel injection pump rack travel held to a certain maximum with a bunch fuel for the diesel engine speed to come up to 540 RPM is necessary to give it the speed to 550 RPM. If it's not possible to do it, with further increase the speed, fuel because the cam prevents the fuel of the rack travel to increase. The load control rheostat will now be operated with the governor with the rheostat to reduce the generator loading. Load is removed with the generator diesel engine speed will become the 500 until 550 RPM is reached the speed with the balance. At this point, the governor will hold at 550 RPM until the throttle is moved again. The complete action of the load control of the rheostat will be described in load control. When the engine main coupled with the more diesel engine with the speed with the more horsepower with the notching of the throttle with the fourth notch for the governor increase the fuel and increase described in each of the effect of the throttle movement of the governor. However, in order for the operation described to take place with the fuel limit must be determined a bit in order for the arms A and B with the move with the right and increase the fuel with the turning of the cams accomplishing with the action of the governor's second pilot valve with the fuel limiting pilot valve fuel limited in of this pilot valve is supplied with the current locomotive the battery circuit with the engine throttle with the third notch therefore by within 475 milliamp the circuit and control circuit with the fuel limited coil the curl will be the current will be pulled the plunge downward and just enough to block off the little inlet port and prevent the oil from exerting pressure on the slave piston. Number 2, the throttle 2 throttle is advancing from 3 to 4 with the speed relay ABS to operate with the control relay stat 13 132B for the output fuel input limit and circuit with the illustrate with the complete with the fuel limit circuit with the refer to table 4 with the speed relay operation reduction the circuit with the resistance permitted with the higher current flow with the fuel limited limit coil more than 475 milliamp to decrease with the current pull of the pilot valve plunger to opening of the inlet portion of the plummet will force to the slave piston number 2 down as the position piston goes down in the turn shaft H with the counterclockwise move with the shaft turns to the fuel limit of the cam when it's keyed open onto it and arms A and B will then move into the right increase the fuel the cam will only turn a little however the arms will hit the engine hit again and the fuel will become new value will be at a new value horsepower will be increased accordingly. As shaft 8's turn for the brush arm with the fuel light limit with the rheostat 132 with the trade figures 24 and 36 with the well with the fuel limited cam with the rheostat brush arm adds with the resistance of the fuel limiting coil figure 36 the resistance increased due to the butt moving the brush arms current through the fuel limit and gradually reduced once again with the drop to 450 milliamp with the permits the reference spring with the pull the plunger far enough with the balance of the port with the cutoff of the oil flow the cam is used with the turn the exertion the distance and thereby give the definite fuel limit of each position engine throttle with the show of the fuel limit rheostat and brush arm. The figure 24 does not show the reference ring with the fuel limit valve that one exists. The same position of this valve is shown in speed pilot valve. Load control. See page 7. The governor of load control controls the speed of the diesel engine by preventing the traction generated from overloading the engine during the operation of the notches 3 and through 8. The governor's arm A and B with the push against the fuel lifting cam. The arms can contact with the cam in each of the throttle position. Normal the arm against the cam position because of the ensure of the engine for the receiving the full quota of fuel, particularly with the throttle position. The only few periods of locomotive operation maximum available fuel will be hold the engine in its proper speed. However, the periods during the fuel was sufficient to maintain the engine speed. Transition position to the other points with the normal power output with the generators equal the engine ability to supply power. All other periods operation necessary with the control of the generator loaded with to prevent the slowing of the engine down with the rated speed, but let the assuming the engine advance with the throttle 2 notch for the notch 3. This cover the arm and B to move to the right, increase the fuel, the increase of the fuel, the contact fuel limit the cam, the increase of the fuel they're non-prevented. And generator load heavy enough to hold the engine speed of 550 RPM with the normal 3rd notch to be, but the tachometer generator will also be low. Normal. The speed value current was less than 450 milliamperes. With less than 475 milliamperes, the speed coil speed pilot valve plunger pulled up for the reference ass ring with the movement of the plunger. Open the pilot valve inlet port with the allows oil pressure to the slave piston number 1 further up the shaft E. The term clockwise lever to the arm D with both lever C. Now the further becomes a mechanical link to arm A. The lever has been stopped at the fuel blind and then cam the shaft to E, but winds up with the over treble spring D moved away from the C and D. Leave the C brush arm to load with the control of the rheostat 125 begin with the travel to XF. The rheostat segment the brush arm adds the resistance to the exciter field current with the C37. The exciter field current with the force of the weak due with the increased resistance load control rheostat. The force of reduction with the exciter current with the terms of the reduction of the generator field of the current. Reduce the generator field lightness of the load with the generator and left the generator with the engine speed up to around 100 RPMs. The governor of the diesel engine certain definite amount of the fuel and actual control of the diesel engine speed with controlling the amount of the generator load. The cam is restricting fuel injection certain amount of the load control rheostat engine with the rated speed of removing the load from the generator. If the load should drop on the generator, the engine would course with increased speed of the load rheostat brush arms, then force down to the board, reduce the resistance to allow the load to increase sufficiently to slow the engine down to rated speed. Or your basic excitation circuit. You have your main generator, an exciter with a field winding GS and GS5. Your exciter field winding 1 and 2, 152 rheostat and tubing rectifier, 1 field winding and a transformer from the 400 circuit AC generator or alternator. Or recalibrating linkage. Recalibrating linkage provided with all the correct position of load control rheostat, each position, engine throttle with the fuel limited shaft. The turn move become different every time the throttle is moved. Also, turn the barrel with load control rheostat. The barrel rotates the shaft to move with the rheostat face the normal position. New position tends to move with the segment away from the rheostat, away from the brush away. It was not done with the load control brush arm, but would sweep across the rheostat face with the excitation, unload with the generator every time the throttle was advanced. Figure 24 shows the recalibrating linkage because this the 2 knobs and the bell crank with the connection shaft H with the load control rheostat barrel 125 actual barrel is moved the gear against eccentric with the linkage that's shown in figure 41. Stabilizing action. Without some of the stabilization, speeding of the action, but the governor would tend to be very ragged. As for example, slow down the engine speed would be followed by speed acting to cause the fuel increase. With the increase of the fuel deep, delivery to the engine would be continued until the engine had been regained its rated speed. If the edge reached the point of the tachometer generator, but it couldn't be the balance with the pilot valve. However, the pilot valve inlet with the power port will be immediately closed off by the plunger to prevent any further fuel increase. The diesel engine monument would be carried to speed above the rated RPM. The action would cover the tacho generator current, but to become strong enough to cover the pilot valve to force the fuel. To decrease the diesel engine slow down, the cycle would take place in the reverse to cover the diesel engine drop the rated speed. This is up and down, the action referred to as hunting. The minimizing tendency of the diesel engine hunting and stabilizing coil with the pump of the pilot valve helps the speed of the coil steady with the diesel engine speed. Whenever the speed of coil causes the pilot valve plunger to move to the balanced position, stabilizing coil partially open opposite with the movement that tends to prevent the pilot with the valve plunger with the opening in the port too widely. Refer to figure 24 with the brush arm with the stabilizing rheostat 125 with the turn with the E of every shaft to E the turn laterally away from the turns of the war whenever the pilot valve plunger is forced into position of a balanced position. This is whenever the pilot valve is causing an increase the decrease in the fuel into the diesel engine. Stabilizing rheostat is connected with the stabilizing coil with the circle in which the man of the movement if the brush arm will change the resistance with the circle of the resistance chain with the capacitor movements force with the current with the stabilizing coil sits up with the second magnetic field with the pilot valve solenoid. The stabilizing coil magnetic field will be opposed with whether the movement of the plunger will cause the speed of the coil. This tends to prevent the speed of the coil from moving the plunger far enough to cause a radical change in fuel delivery. Stabilizing coil magnetic pull is never strong enough to have completely overcome the pull of the speed of the coil. The only partial opposed to prevent the overshot of the diesel engine speed. The stabilizing rheostat is actually shown in figure 41 and 42. For figure 24 shows the brush arm mounted on shaft A with the actual shaft E rotate the brush arm that means for the gear of the train shown in figure 44. Assume the diesel engine slow with the rated speed of the pilot valve operating with the pressure to reach the move of the slave piston over the upwards into the cylinder. The turn shaft E of the brush arm with the stabilizing rheostat rotate with the gear which connects with the shaft. The shaft E with the arm bolt brush arms move in the reduce the resistance. The stabilizing current circuit with the permit the voltage increase on the 50G wire side of the capacitor 128 with increase the voltage on one side of the capacitor 4 for the capacitor discharge the current through 127 rheostat with stabilizing the coil through the current cause the stabilizing coil with the pilot valve plunger to partially close the inlet port, preventing the heavy and oil flow with the moving the slave piston too far up in the original upward movement of the pilot valve plunger is partially opposed. This starts out with a start on the engine control in idling side switch. 125 stabilization and control ISR energy control coupling 50 wire 128 and 127 rheostator system CVS battery switch stabilizing coil back to the stabilizing rheostat. Or to wind the stabilizing coil and set the current with the flow through the B with the B to the B from B to the H will cover the pull the pilot valve plunger down with the partially open the fuel increase with the preventing the rate of fuel increase with such acceleration and speed overshooting with the diesel engine are avoided. When the diesel engine will decrease with the speed above the normal rated RPM with the pilot valve with the axis decrease to prevent the make of the great decrease with this radical resulting radical drop in the engine speed stabilization coil and again opposing speed coil with the action. In this case, the slave piston turns the shaft E with the stabilizing rheostat breath the arm move to add resistance with the circuit breaker to decrease the voltage 50G wire on the side of the 128 capacitor engine. Again, the capacitor causes the transient current flow for the time of the opposite direction instead of the current flow from B to H through the oil with the now flow for the H to B. This current flow for the pilot valve plunger is pulled with the partial flow for the inlet port, preventing the slave piston from moving too far down. This action effectively prevents the too great of the degrease in fuel. This stabilization coil is acted to prevent pilot valve plunger from being pulled too far down. When stabilizing coil acts to prevent the greater decrease of the fuel current with the flow of the coil weaker than it was to great and increase with the fuel is beginning with the preventing with the current flow with the HB is weaker with the wind is flow through B to H due to the action of 126 blocking rectifier. This action is illustrated in the stabilizing core circuit analysis in figure 39. When the circuit can operate with the prevent with the greater increase of the fuel, the current flow of the capacitor 128 through the 126 rectifier through the part 127 resistor and also the 127 resistor. The reverse direction current flows through 127 all of the 127B resistors through the CVS interlocking capacitor 128. The current which will now weaker the discuss the big of the resistance will use the greater 3 the incident of these notches and the throttle notches the T3 T08 and CVS coil with the energized interlock that will open the resistor 127A will then be in a circuit with the current will be still weaker. Alright, this shows your arrows will indicate the direction of the current flow, referring to figure 38 with a complete stabilizing circuit. Alright, you have a coupling with 128 through the 127 rectifier and resistor, rheostators 127 and 127B, stabilizing coil field wiring G through H. Alright, stabilizing current with the flow, the preventing great increase of fuel. Stabilizing prevents the increase of the fuel 1 to second to throttle. Coupling 128 is the CBS connection, the 127B, 127 rheostat, stabilization coil figure 39. Stabilizing prevent flowing to prevent the greater decrease in fuel third position, the 8 throttle notches. Coupling 128 rheostat, 127 and 127A, 127B, 127A, stabilizing coil. I read that backwards. Alright, I read those backwards. Or the stabilizing circuit just described the stabilizing bug with the action speed with the preventing overshooting and undershooting with the engine speed. However, during the condition for the generator loading and unloading, instead of the blocking action with the need, for instance, of the increased load will slow the engine down with the drop of the time lag between the drop of the speed with the governor response to it. To eliminate the time lag, circuit is connected between the amplifying exciter and the stabilized coil, as a diagram figure shows. The amplifying exciter exploit is coupled with the anticipation circuit 121, 128A, and the stabilization coil. Or change in loading and unloading always proceed with the change with the exciter voltage of the chain with the act upon the capacitor 151 in such a manner that the change with the voltage of the act upon the capacitor 128. This will cover the transient flow of the current across the capacitor. The current will act upon the stabilizing coil in such a manner that it cover the operation pilot valve before the tachometer generator fall for the operation. In other words, increase the load 10 with the decrease the engine speed before the speed increase with the call with the tachometer generator to call for the more fuel with the drop of the amplifying output with the already had started with the stabilizing engine coil to active with the increased fuel with the stabilizing coil anticipates the need for the engine for the before the diesel engine actually begins to slow down. The circuit work with the reverse in exactly the same manner. Stabilizing coil acting to decrease the engine fuel before the engine requires the decrease in the fuel. The feedback is always proportional to the rate of the load change. The greater the load change, the stronger will the current will flow for the exciters of the stabilization coil. The blocking rectifier 126A allows the heavier current to flow through the stabilization coil with the fuel with the decrease. The rectifier permits the current to be flowed around 21 resistor. In this case, the fuel increase the coil with the current flow with the from H to B through B will be weaker because the rectifier forces the current from the resistor 121. Our figure 35 illustrates the connection of the capacitor 148 with the speed circuit with this capacitor act with the current booster with the engine speed with the increase of the call for the reduction of the fuel with the desirable degree of the fuel is rapidly impossible is possible. This increased tachometer generator voltage call to the capacitor to discharge current through the speed coil with the action pull without the pilot valve down quicker than would be case would be the case if the capacitor was not used with the fuel current rack with the injection pumps moved quickly to increase the fuel. The capacitor action is only momentary, serving to produce initial water corrective the opening of the pilot valve port with the strength of the capacitor of the current discharge depends on how fast the diesel engine speed changes. The greater change in speed will result in the more current with the wider corrective pilot valve with the opening, then the slight speed changes. Capacitor 148 also reduces the current surge in the speed coil circuit whenever there is resistance for the circuit that suddenly increases when the throttle is advanced. One notch the action tends to prevent the sudden acceleration of the engine in a condition which would set up the severe mechanical stresses. Are your protective devices. In order to regulate the operation of the diesel engine, the governor clutch coil must be energized to power from the batteries. If the coil is de-energized, it will allow the clutch arm A and B to separate the clutch arm B, then return to the shutdown and no fuel position of the engine stop. The protective devices are incorporated with the control circuit, clutch circuit as follows. The governor oil pressure switch, GOP, the governor oil pressure drops 75 pounds per square inch. GOP opens at 50E and 50F. Contact wire, contact the desired de-energize with the clutch coil, thereby shutting down the engine. GOP is your general governor oil pressure switch. All right. Your safety relay is your ASR and opening within in the speed setting with the circuit degree energized with the safety relay. Coil opens the safety relay at 50C and 50T. Contact clutch coil current with the coil circuit with the same resistance of the general oil pressure switch. The safety relay. Contact 50N 50EP. The stab circuit with the close with the energized stable with the coil with the force the arm to shut down position. This action protects the diesel engine against the sudden increase of the speed, which would result in the speed coil circuit tail with the pilot valve plunger to be pulled upward by the reversing spring. Your overspeed switch is the OS. If engine speed with 110 to 120, 1100 to 1120 RPM, the upper overspeed switch is tripped, thus opening 50H and 50E with the contact coil circuit to shut down the engine. Let's say you have your governor oil pressure switch, your safety relay switch, your overspeed switch. A drop in the oil pressure of 20 pounds per square inch below opens the OPSR or the engine oil pressure switch. This de-energizes the oil pressure relay, OPR relay, which is later de-energized the oil pressure relay interlock with the speed circuit of the control. The circuit returns the engine idle speed. This action takes place only in the locomotive the operating in the fifth notch or higher. This is below the fifth notch. The operating coil, the oil pressure coil will remain energized even when the oil pressure switch 1, and the diesel engine will not drop to idle. Further drop the oil pressure 7 pounds to the square inch below the OPS 2. Oil pressure switch 2. The 50T and 50D contact de-energize with the clutch coil, shutting down the engine. Ground relay operates with the GR interlock with the speed control circuit with the clove. This with the interlock clove with the 132 resistor with the circuit air bypass, but the engine will drop to idle speed. When traction motors are cut out with the rheostat 130 added with the fuel limit circuit is when CO contacts with the 31Q, 31W opens, the figure 36 will increase the resistance and reduce the current flow with the circuit with the fuel limit the cam stops in position with the restrict the fuel rack travel by restricting the fuel diesel engine horsepower, reducing the remaining traction motors that are not overloaded. Figure show that this is CO or connected at rheostat 130. Normally the current flow to the CO 130Q and 131W with the contacts open. The motor cutoff switch and the current is then forced to flow through 130. Your actual linkage. Alright, figure 24 shows the recalibrating linkage represented with the 2 rods and bell crank previously mentioned with the mechanical schematic diagram speed with the various devices apart with the clear reviews. Actually, the rheostat barrel is rotated with an eccentric link with is also operated with the gear and shaft H with the figure 41 front view of 17 MG3. Governor illustrates the recalibration linkage. Figure 44 illustrates shaft E and H with the respective gearing. Note the brush arms of both the fuel limited rheostat 131 and load control rheostat 125 are actually operated through the gearing rather than direct drive, as shown in figure 24. The actions of these brush arms, however, is described in the foregoing test. Additional illustrations, figure 42, a review of the governor showed that the spring load with the governor oil with the pressure regulator with the cutout ways. Figure 45 illustrates another view of the review of the governor A, B, and arms removed from the show of the position of fuel limit cam. Figure 46 illustrates an exploded view of the governor, and figure 43 shows the drawing of the speed pilot valve assembly. Let's back out of this to zoom page level. Alright, this is your front part of the type of the M17MG5 governor. You have your oil outlet, your fuel limit rheostator, your stabilizing rheostator, your connector plug, your load control rheostator, the connector, the speed control solenoid, the slave cylinders, recalibrating linkage, fuel limit solenoid contactor. Rear view of the type of 17MG5 governor. You have your solenoid load control rheostator, the stabilization rheostator, traveling spring, and that's right, 75. Your oil inlet, your oil outlet, oil pressure regulating chamber, governor off switch, A arm, bid springs, B arm, and clutch coil. Your governor solenoid shows the 02 fuel inlet, 01 speed solid, clevis no spinner, aluminum non-magnet, so brass top, copper thinner, springs, arm strap, black washers, 2% silicone iron, special magnetic material, arm stop, steel, standard kernel, turbine 50 to 100, 2,000 RPMs, low ion speed, 1 speed control solenoid. It says your governor wiring, sulfur top in the turbine pilot valve turn plunger reference spring gasket 132-inch gasket 164-inch movable core American pipe fanalical plugs and AN connector speed control stabilizing aluminum once again Powerplant govern the diesel engine, one plane's circular view. Figure 47. Rear view of the Type M17 GM3 arm is revoided with the clutch coil exposed. Level C, governor arm off switch, shaft H, inlet fuel limit cam, clutch coil, oil pressure regulator, oil outlet, oil inlet, lever D, stabilizing rheostator, over travel the rheostat, spring assembly solenoid, level C. Arm B, arm A, output shaft support, bearing pin, shaft H, bias springs. Alright, 1, you got a bolt. 2, you got a pilot valve bracket. 3, the pilot valve cap. 3, the bracket. 4, the cylinder head. 5, the pilot valve cap screw. 6, the cylinder head gasket. 7, the fuel limited solenoids. 8, the speed control solenoid. 9, the slave pistons. 10, the wiring harness. 11, the amp plugs. 12, the piston stops. 13, the nozzle ring screen. 14, the plug. 15, the nozzle ring. 16, the plug. The 17, pressure relief valve piston. 16, pressure relief valve springs. 19, oil pressure adjusting plug. 20, 21, governor base plug. 22, governor base. This is your speed regulating control, load control, rheostat, over travel spring, blocking spring, fuel limit cam, clutch spring, B, fuel injection pump, stabilizing rheostat, slave piston 1, 2, fuel limited pilot valve, fuel limit control, stabilization, inlet port, preference spring, inlet port, rheos rectifier, fuel tank, tachanometer, generator. Alright, Section 4, Power Plant Regulating System of the 1950 locomotives equipped with the Type 17 MG Governor.